Elon Musk has just dropped a surprising hint about the emergence of a new engine iteration dubbed Raptor 4. This revelation comes as quite a shock considering it arrives less than a year after the testing of Raptor 3. Now, what sets Raptor 4 apart from its predecessors? What makes it stand out in the realm of rocket engines? Well, the answer will be revealed. So join us on today's episode of Alpha Tech as we delve into the intricacies of Raptor 4 and explore its groundbreaking features and capabilities compared to other rocket engines on the market. Get ready to witness the next evolution in rocket propulsion technology. On April 7th, Elon Musk, the esteemed CEO of SpaceX, unveiled significant details about the upcoming engines set to be produced by the company. In a momentous speech delivered in front of the entire SpaceX team, Musk shared insights into the future of propulsion technology. He stated,
And I think ultimately the booster engines will aim to get the booster engines over 330 tons of thrust.
This ambitious declaration hints at SpaceX's relentless pursuit of innovation and improvement in engine performance. For context, it's important to note that SpaceX has already made impressive strides in engine thrust. With the Raptor 3 engine, the company achieved a remarkable increase in thrust, elevating it from 185 tons to 280 tons. This leap in performance underscores SpaceX's commitment to pushing the boundaries of rocket propulsion technology and sets the stage for even greater advancements in the future. Elon Musk recently engaged in a discussion about the highly anticipated Raptor 4 engine, responding to a user's post on X. The post drew parallels between the emergence of Raptor 4 and the unveiling of Starship 3, part of SpaceX's new Starship scheme, which includes 3 upgrade versions announced by the company. By extrapolating from the data of the booster with a thrust of 10,000 thrust force, it's straightforward to calculate that Raptor 4 would have a thrust of approximately 303 thrust force. However, Musk emphasized in the comment section his aspiration for even higher thrust, stating, hopefully higher thrust. Long-term goal is 330 thrust force. Even with a projected thrust of 303, the Raptor 4 engine's power is nothing short of extraordinary, nearly equivalent to half the thrust of the legendary F1 engine that propelled the Saturn IV. Musk's aim for the thrust of this new Raptor variant to reach up to 330 thrust force speaks volumes about its formidable potential. To fully grasp the magnitude of the Raptor 4 engine's power, let's consider an optimistic thrust figure of 303. Now, let's take a look into the graphics of the Raptor engine versions, even though we lack an image of the Raptor 4. Based on the enhancements from Raptor 1 to 2 and then to 3, it's safe to assume that 4 will be designed even more compactly. If we consider that Raptor version 1 has a mass of 2,000 kilograms and version 2 has 1,600 kilograms, then it's plausible that version 4 will have an approximate mass of 1,500. Coupled with a thrust of 303 thrust force, this yields a thrust-to-weight ratio of 202. This figure is truly mind-boggling, especially when compared to the benchmark of the Merlin 1D engine, which stands at 180. The thrust-to-weight ratio is a critical metric for rocket engines, reflecting their efficiency and power. A higher TWR indicates a more capable engine that can accelerate the rocket faster and achieve greater altitudes. In this context, Raptor 4's TWR of 202 surpasses the dominance of the Merlin 1D, placing it at the forefront of rocket engine performance. Indeed, when we examine the thrust-to-weight ratios of various rocket engines, we find a fascinating hierarchy of performance. For example, the Space Shuttle's RS-25 engine holds the lowest TWR at 73:1, followed by the RD-180 at 78:1, and the BE-4 at approximately 80, though precise data for the BE-4 is not readily available. The F1 engine boasts a TWR of 94, while the Raptor 2 leads the pack with an impressive ratio of 107. While details about the Raptor 4 engine remain scarce, Musk's revelation signals a significant advancement in engine technology. This achievement underscores SpaceX's commitment to innovation while navigating resource constraints. It's a testament to their ability to strike a balance between pushing boundaries and maintaining sustainability in their endeavors. As for whether Raptor 4 represents the final iteration of SpaceX's engines, the answer remains uncertain. With the limitless potential of Starship and fewer constraints, SpaceX has the opportunity to continue exploring the frontiers of rocket physics. Every advancement brings them closer to optimizing thrust and efficiency. further propelling humanity's journey into space. What are your thoughts on the future of SpaceX's engine technology? Join the conversation and share your insights in the comments section down below. As we embark on this exciting journey, let's marvel at the remarkable progress SpaceX has made and anticipate the groundbreaking innovations yet to come. Meanwhile, in a recent address to all company employees, Musk highlighted the evolutionary journey of the Raptor engine, outlining the significant improvements made from its inception to the present day. Since its debut in 2016, the Raptor engine has undergone a series of continuous enhancements, progressively becoming more powerful and efficient with each iteration. SpaceX's unwavering commitment to pushing the boundaries of rocket engine technology is evident throughout the development journey of the Raptor engine. The initial iteration, Raptor 1, served as a pioneering testbed for innovative concepts. Its successful tests in 2020 marked a pivotal moment in the advancement of rocket engine technology, laying the foundation for subsequent developments. Building upon the success of Raptor 1, SpaceX introduced the Raptor 2 engine, which boasted increased thrust and chamber pressure, thereby enhancing overall efficiency and performance. This iteration represented a significant step forward in the evolution of the Raptor engine. In May of 2023, SpaceX unveiled the Raptor 3 engine, showcasing the remarkable results during its inaugural tests. While not the final version, the third iteration represents a substantial leap forward in engine development, featuring enhancements in performance, efficiency, and overall capability. The iterative improvements to the Raptor engine underscore SpaceX's dedication to innovation and continuous improvement as they strive to redefine the possibilities of space exploration. With each iteration, the Raptor engine brings humanity one step closer to realizing the ambitious goals of interplanetary travel and colonization. The introduction of the Raptor 3 marks a significant advancement by eliminating the need for a heat shield, resulting in a simpler yet more integrated design. Despite its seemingly stripped-down appearance, the Raptor 3 incorporates intricate features such as integral cooling channels and secondary plumbing, addressing complexities while enhancing ease of integration, performance, and reliability. While its construction posed challenges, the Raptor 3 promises improved functionality, reduced mass, and heightened dependability. Looking ahead to Raptor 4, SpaceX aims to push the boundaries further by achieving even greater thrust and reliability, signaling potential advancements in rocket propulsion. As such, there will likely be considerable speculation surrounding the future iterations of the Raptor engine. SpaceX's approach to engine development emphasizes rapid iteration and continuous improvement, with a focus on gathering data and implementing refinements for subsequent versions. The transition from Raptor 3 to SpaceX's Starship version 2 prototype suggests an evolutionary trajectory wherein each iteration serves as a stepping stone towards the optimized design of the Raptor version 4 engine. This iterative process, while not without its challenges and setbacks, is integral to SpaceX's ethos of innovation. By introducing intermediate versions of engines, SpaceX can experiment with new concepts, identify areas for enhancement, and fine-tune performance to achieve optimal results. Indeed, the path to innovation is fraught with obstacles, and the development of the Raptor engine has encountered its share of challenges and failures. However, SpaceX's commitment to pushing the boundaries of rocket technology remains unwavering, driving forward progress in space exploration and propulsion. Despite facing obstacles, SpaceX remains steadfast in its commitment to developing the Raptor engine, recognizing its significance not only in terms of power, but also in optimizing time, cost, and performance in space exploration. SpaceX has set ambitious cost targets for the Raptor engine, aiming for a production cost of less than $1,000 per ton of thrust, equating to approximately $250,000 per engine. Achieving this goal would enable cost-effective production, facilitating the scalability of space exploration endeavors. In 2022, SpaceX announced its capability to produce one Raptor engine per day at its McGregor facility in Texas, demonstrating significant progress towards meeting production targets. A key feature distinguishing the Raptor engine is its utilization of liquid methane and liquid oxygen as fuel sources, a combination known as methalox. This choice of fuel holds strategic importance for space exploration, particularly for missions to Mars, as both methane and oxygen can be potentially generated from Martian resources through in-situ resource utilization, or ISRU. ISRU is vital for establishing sustainable human presence on Mars, as it enables the production of propellant using locally sourced materials, reducing reliance on Earth-based supplies. Furthermore, the use of methane as a fuel offers environmental benefits, as it burns cleaner than traditional rocket fuels such as RP-1 kerosene, resulting in fewer pollutants. The Raptor engine's exceptional power is instrumental in facilitating human travel to Mars, enabling spacecraft to achieve achieve unprecedented speeds and efficiency, thereby advancing the feasibility of interplanetary exploration and colonization. The Raptor engine's development underscores SpaceX's commitment to advancing reusable rocket engine technology with a focus on maximizing reliability in even the most challenging environments. Through rigorous testing and continuous refinement, SpaceX aims to ensure that the Raptor engine becomes a cornerstone of reliable propulsion for future space missions. Beyond its technical prowess, the Raptor engine plays a pivotal role in SpaceX's broader vision of revolutionizing space travel. By driving down costs and increasing accessibility to space, SpaceX seeks to pave the way for ambitious endeavors such as establishing a long-term lunar base and creating the first self-sustaining colony on Mars. This vision aligns with Musk's ambitious timeline, which includes sending an unmanned Starship to Mars following NASA's Artemis missions to the Moon, potentially by the mid-2020s. Musk envisions the possibility of establishing the first human settlement on Mars before the year 2050. As SpaceX continues to refine and integrate the Raptor engine into its spacecraft, we can anticipate further strides in space exploration and travel. These developments hold the promise of unlocking new frontiers in human exploration, ultimately shaping the future of interplanetary civilization.
SpaceX is a giant in the field of private space exploration, and they continue to surprise us throughout their operations. Right now is no exception. SpaceX and Elon Musk have finally unveiled the design of the new Starship prototype V3, unlike any other vision, and that gives us a clearer view of the remarkable upgrades it brings. So, what has Elon just revealed about the new Starship V3? What makes it so impressive? What's the difference between Starship V3 and V2 and V1? Starship is currently the largest rocket ever built by humankind, including the first stage named Super Heavy, standing over 120 meters tall in total. SpaceX has conducted 3 orbital test flights so far. 2 took place in 2023, and the last one was in March, which was very successful. But Elon's company is now researching something even bigger. These are Starship V2 and V3, presented in the presentation slides. How will these guys differ from the current test design? First, you can see that Starship V2 is slightly taller than the current prototype, with the spacecraft's height increased by an additional 2 meters and the booster's height increased by 1.3 meters. The increased load-bearing capacity and thrust during liftoff enable it to carry more than 100 tons. The new version of Super Heavy is expected to provide about 15% more thrust than the booster used in the March test. In fact, Starship 2 will be the first version of SpaceX's rocket to operate fully and allow it to deliver cargo into space. Elon declared that SpaceX has launched more cargo into space than missions conducted by other companies or nations. When Starship can fly regularly, the success rate increases to 99%. However, looking at Starship 3, this is when some upgrades really come into play for a much taller spacecraft that looks like a clearly elongated version. With the thrust expected to be improved compared to Starship V1 and V2, Starship V3 could increase from 7,000 tons of thrust of V1 to over 8,000 tons of thrust for V2, and eventually over 10,000 tons of thrust for V3, as Elon shared during the presentation. This results in the payload capacity of Starship V3 doubling that of Starship V2, exceeding 200 tons, surpassing all current vehicles. Starship V3 will stand at 150 meters tall instead of 124.4 meters of Starship V2 and 121.3 meters of V1. And it may even be taller than the current launch tower at Boca Chica. At that size, the 2 stages of Starship V3 are nearly identical. The fins also look slightly larger and may even be fixed in place. With these improvements, Starship V3 will accommodate 4,050 tons of fuel in the booster and 2,300 tons in the ship, larger than the 3,650 tons in the booster and 1,500 tons in Starship V2. In terms of engine count, V3 will feature 6 engines and 3 additional vacuum engines. Starship V2 and V1 will maintain 3 sea-level engines and 3 vacuum engines aboard. Another feature that we notice is the hot staging section of Starship V2 and Starship V3 differing from Starship V1. Instead of the original style vent hole design, now the new version of Starship has an interface similar to the Soviet N1 style of the interstage that's incorporated on board. This has sparked much debate about the endurance of the increased gravitational force on Starship's capabilities when subjected to very high pressures during flight. However, these are just predictions, and we have to wait and see what SpaceX does next. And also in the graphic images, the various versions of Starship have shown us the answer to the speculation of the past when Elon Musk hinted about the new version of Starship. At that time, we speculated that the initial lengthened Starship would be part of the rumored V3 lineup that's currently in the design phase. Starship V2 wouldn't be produced and might get skipped. However, this is no longer accurate, as Elon and SpaceX are definitely going to manufacture Starship V2 later this year and launch them by 2025. This could lead us to speculate that Starship V3 could potentially be manufactured in early 2025 and ready to go in 2026. Of course, this isn't merely speculation, as we've recently seen the first hardware components of the new version of Starship at the build site, proving that SpaceX is ramping up work on Starship V2. Alongside the impressive capabilities of the new version of Starship, Elon Musk also mentioned another very important aspect that Starship will undoubtedly achieve in the future, which is maximizing cost reduction. Musk claimed that the future Starship V3 would cost less to launch than SpaceX's original rocket, the Falcon 1 small launch vehicle, which had a price tag of around $10 million because of full reusability. He estimated that the Starship cost per launch could fall as low as $2 to $3 million.
These are sort of unthinkable numbers,
he said.
Nobody ever thought that this was possible, but we're not breaking any physics to achieve this.
Well, this is beyond our imagination. For instance, if a future Starship costs $2 million to build and $2 million for fuel and operations, then even in expended mode, the payload cost would be $15 a kilogram. Now, considering a $3 million Starship capable of flying thousands of times, the cost would primarily revolve just around the fuel expenses for the flight and minimal overhead. By implementing systems for synthesizing liquid oxygen on site, fuel costs would be substantially reduced. For example, with an estimated $500,000 per orbital flight for fuel and 250 tons of reusable payload, the cost would range from $2 to $4 a kilogram. Similarly, for transcontinental flights, with fuel costs estimated around 125 Gs per flight and the same payload capacity, the cost would be around 50 cents to $1 per kilogram. So
that's the difference between if you've got a fully reusable rocket with low-cost propellant and autogenous pressurization, actually costs less.
This provides an advantage that no other rocket in the world can match. The cost has been a major barrier limiting access to space. Since the 1950s, the cost of traditional space programs made it inaccessible for most countries. And although SpaceX isn't the only private company doing launch services, it's emerged as one of the most important. Nowadays, humans have more opportunities to access space thanks to Starship, and this isn't just leaps and bounds achievable only by billionaires, but it's an opportunity for all of us. Starship will have an immediate impact once orbital testing is completed and safety certifications obtained. Launching satellites and resupply missions to the ISS will be the first steps, followed by sending humans beyond Earth to the Moon and even Mars. As early as 2026, Starship is slated for a lunar mission under a contract with NASA. Starship's reusability and cost savings align with the agency's goal of establishing a more human presence on the Moon, making it a stepping stone for the future. Moreover, Starship itself will be the first outpost on these distant planets. Government planners won't have to worry too much about the emergence of Starship, as it'll serve as a home on the Moon or Mars. Beyond interplanetary aspirations, Starship also revolutionizes transportation here on Earth. With its enormous capacity and rapid speed, the new version of Starship will expand transportation opportunities from one point to another, reducing transit times between distant points, of course, with a reasonable price and Starship being available to everyone, whether government or private entities. Of course, cheaper payloads into space will also lead to more affordable orbital tourism. First, commercial orbital stations will create more opportunities to host tourists. Second, tourists are going to be able to fly on Starship itself. And there are already such contracts. For example, the Polaris program. Jarek Isaacman, the billionaire founder of payment company Shift4, has purchased as many as 3 more flights from SpaceX. The first mission, called Polaris Dawn, scheduled to launch a 4-person crew led by Isaacman in 2024 with the company's Falcon 9 rocket and Crew Dragon spacecraft. Polaris Dawn's the inaugural of up to 3 planned missions, with a final one to be the first crewed spaceflight of SpaceX's Starship rocket. Each such new rocket system makes space a little more accessible to all of us, and the time is not too far away when flights into space will be as affordable as airplane flights. Everything is amazing, isn't it? But in reality, as Starship continues to get upgraded, it'll have even more advantages than we think. Those will be important steps for Starship to get closer to these important goals. It won't only reinforce SpaceX's dominance, but also be a huge benefit for NASA and the U.S. aerospace industry. It can be said that the changes with Starship V3 are truly breaking every limit we can think of. Not simply the limit of the size of a rocket, but it'll be the limit of exploration that humans aim for, beyond the Moon or Mars.
Getting a rocket into space is already challenging, but leveraging its benefits to the fullest is even more daunting. That's why Elon Musk has been continuously tweaking the engineering and design of every part of the Starship, aiming for a rocket that's bigger, stronger, and more efficient than anything ever before. And most recently, CEO Elon Musk has revealed significant changes to the Super Heavy, promising to shake up the space race and leave us all in awe. But what exactly are these changes? How will this benefit SpaceX's Starship program? What are the differences between Super Heavy's new designs and the previous ones? First off, let's talk about the most noticeable change, which is the height of the booster. Right from the start, the Super Heavy booster had an impressive height of 70 meters, equivalent to the entire Falcon 9 or Falcon Heavy rocket, including the first stage, second stage, and payload fairing. However, after the first launch of the Starship full-stack rocket, the Super Heavy adorned itself with a crown called Hot Stage, increasing the total height to 71 meters. And it doesn't stop there. With the aim of reaching what seemed impossible, SpaceX continues to increase the scale of its propulsion rocket. Still maintaining a diameter of 9 meters, the height of Super Heavy version 3 has increased by an additional 13% compared to the current Super Heavy version, reaching 80.2 meters, which is almost as long as a NASA SLS rocket. This will certainly extend the volume of fuel tanks, increasing the amount of fuel the booster can carry. Increasing fuel load could increase the benefits of the life cycle by extending the lifespan of the spacecraft. Alongside the overall length enhancement of the propulsion rocket, the grid fins have also been modified by SpaceX to suit the two versions of Starship. Grid fins are aerodynamic devices used to adjust and guide the flight altitude of rockets and missiles. They're a unique lifting and control surface with a framework of flow channels set within a rectangular structure. The Super Heavy grid fins have undergone some modifications since the first booster that supported them, Booster 4, was constructed. The older design had fewer grid fins spaced more loosely apart, while the newly introduced design on Booster 7 has tighter and wider fins. However, in all Starship V1 versions up to now, they still remain steel grid fins with a black paint job. As for Starship V2 and V3, as observed through SpaceX's graphics, the grid fins seem to become thinner and lighter. This results in a significant reduction in weight for the booster during launch. The 4 grid fins on the propulsion rocket weigh 3 tons each, 6,600 pounds, which is about 20 times heavier than Falcon 9's grid fins, based on estimates I found to be around 140 kilograms for Falcon 9. Well, quite an impressive figure, but anyway, its weight isn't particularly beneficial for Super Heavy. Upon closer inspection, we can also see that the distance of the grid fins on the new Starship version will be further away from the top of Super Heavy compared to the current version. This new design will directly affect the center of gravity of the Starship rocket and the drag force it faces during flight. However, these must be based on numerical data for calculation. The basic calculation is quite simple. During any phase of the flight where the grid fins are required, you must determine the following factors: the location of the center of the gravity, the position of the pressure, the magnitude of destabilizing forces, the mass of the vehicle, the distribution of that mass, specifically the rotational inertia of the vehicle, the velocity, the distance between the grid fins and the CG, and the effectiveness of the grid fins in generating force relative to their size. Because of this, to explore the efficiency of new grid fins in the flight process of Super Heavy, we still need to wait for further updates from SpaceX. Next, one of the most interesting changes to Super Heavy that I find fascinating is the complete overhaul of hot staging. Hot staging is a technique that the Soviet Union and Russia have used for decades. It involves igniting the engines on one stage while still attached to its lower stage. This has the potential to allow for payloads over 10% larger to reach orbit as the thrust is not momentarily halted during the launch process. Elon Musk and SpaceX have applied this great engineering knowledge to their Starship rocket. Not surprisingly, it has performed extremely well and delivered a spectacular performance. However, right from the start, SpaceX's hot staging design for Starship has been different from Russian rockets. When looking at various Russian rocket types, we often see a metal structure resembling a fence separating some stages. As far as I understand, for example, R7 family, Vostok, Vokshad, Soyuz, and the N1 all use this fence design. SpaceX has transformed this basic design by adding shields to protect the upper portion of the stainless steel booster from engine explosions, and adding a metal, meter-wide skirt between the Super Heavy booster and the upper stage of Starship, a new feature that allows super hot engine exhaust from the upper stage engines to escape from the enclosed volume between stages. When looking at the newly updated graphics, it is clear that SpaceX has decided to change the concept for the booster's hot stage. Instead of dividing it into two separate parts, it seems like SpaceX is aiming to integrate the hot stage into the booster, resembling entirely the N1 style fence design of Russia with interlocking struts. With the increased weight of Stage 2 and the accompanying increase in dynamic pressure during max Q, I don't understand how this separation could occur. Although the tubular thrust structure is very efficient and relatively easy to make, by choosing the optimal tube diameter and wall thickness, one can design a very lightweight thrust structure. Such a structure must be lighter or lighter than the current design and easy to manufacture. But is it a viable option that can withstand all that pressure? We still have to wait for SpaceX and Elon to provide more specific information, but it'll be soon because SpaceX has begun the production of Starship V2, expected to launch in the next few months. Well, do you think that that's the end of the multitude of Starship changes? Not quite. Another upgrade that we can see through the Starship graphics is the removal of the shields surrounding the 33 Raptor engines by SpaceX. This partly relates to SpaceX's engine manufacturing. With Raptor 1, not to speak of the power, but in terms of appearance, we could see it was overly complex with a jungle of small pipes, cables, sensors, and valves protruding from the engine like a tangled mess of hair. Surely you need to know that if any of these pipes were damaged from external impacts, our engine wouldn't operate stably. For its offspring, Raptor 2, it has removed much of this clutter, but still some parts protrude and still require a shield layer to protect against high-speed projectile fragments. But ultimately, Elon's goal is to simplify the rocket components further. And that's where Raptor V3 and V4 engines come in, not only sleeker and simpler, but also pushing power to the highest peak ever achieved by any rocket. 330 tons of thrust is what Elon sets for Raptor V4 in the future. Raptor 3 and 4 will have no protruding holes, so the engine will continue to operate even when the surrounding environment gets harsh. It's also undeniable that removing the shields is a clever way to eliminate some excess weight from the vehicle. Based on all these changes and Elon and SpaceX's efforts to make a difference, we can see that this is the optimal method for rocket performance. It's not just a Starship that's the tallest and most powerful ever constructed. It's a Starship that's taller, more powerful, and beyond, meaning there's no limit to this development. However, to progress towards an even more fantastic new rocket version, SpaceX may still need some more time to achieve this important milestone. SpaceX's iterative processes of refining and enhancing rocket design and production often yield such outcomes. This approach reflects the company's ethos towards hardware and software development. Rather than progressing slowly and meticulously from concept to a predetermined final product, SpaceX opts to create, test, and refine the minimum viable product. Over time, they iteratively enhance or replace previous concepts, designs, and hardware until they achieve their overarching objectives. SpaceX's approach with Falcon 9 and Falcon Heavy involves starting with Falcon 1, a basic proof-of-concept rocket. Once Falcon 1 successfully reached orbit, SpaceX expanded its development program to focus on Falcon 9, initially aiming for a full-scale expendable rocket. Since Elon founded SpaceX back in 2002, the ultimate goal has been to create a fully reusable rocket. However, rather than trying to solve all the challenges at once, the company has opted for a more sustainable and practical approach, tackling specific problems one step at a time. These adjustments represent a significant evolution, with the company actively producing Starship hardware. With data and insights derived from testing the complete Starship rocket, SpaceX can now refine the next-generation rocket's launch debut with an unprecedented precision. That's all for today's episode. Thank you so much for watching, and we'll see you next time.